Example 1.5 electric field. 2 point charges Q1 negative 2 nanocoulomb and Q2 positive 3.2 nanocoulomb are placed 3 cm apart as shown in figure 1.5. Determine the magnitude and direction of the resultant electric field intensity at point M. Write down information given. Q1 is negative 2.0 times 10 power of negative 9 coulomb. Q2 positive 3.2 times 10 power of negative 9 coulomb. And then R1M is here from M to charge Q1, which is actually R1M is 5 cm from theorem Pythagoras. So 5 times 10 power of negative 2 meters. And then what you have here is R2M. R2M is 4 times 10 power of negative 2 meters. So R2M is, we label here R2M from Q2 to M. And then we have to determine the theta there, where this is your theta. Okay, so what actually we can do is sine theta is 3 over 5. So you will get sine theta is 0.6, while cos theta is 4 over 5, right? Which is 0.8. Next step is you have to sketch the electric field intensity at point M. So now this is your M, and then what you have here is electric field intensity at point M, and also charge Q1 which is negative. Then E1M is towards the charge Q1. How about E2M? E2M, because the charge Q2 is positive, so E2M is to the right. Okay, then you have your direction there. Okay, and also you can sketch here. Here you label is as E1M, and then here you can label is as E2M. Okay. Okay, and then next is label it E1M, right? Okay. Next step is we calculate the E1M. So your E1M is, okay, I write here, 1M is K Q1 over R1M squared. So your E1M will be 9 times 10 power of 9, and then Q1 is 2, of course, negative 9, no need negative sign. R1M is 5 times 10 power of negative 2 squared. So you will get your E1M, which is 7.2 times 10 power of 3 Newton per coulomb. Next is E2M. E2M is K Q2 over R2M squared. Your E2M, 9 times 10 power of 9, your K. Q2 is 3.2 times 10 power of 9, and then R2M is 4 times 10 power of negative 2 squared. E2M is 1.8 times 10 power of 4 Newton per Coulomb. Okay. And because you have E1M, you have two dimensions, you have X and Y component. E2M is just in X component. So now you write down here in a table, construct a table. So here you have field, electric field intensity. Now down here you have E1M, and also you have E2M. And then here you have X component, which is unit Newton per Coulomb, and then you have Y component, which is Newton per Coulomb. And then here E1M, you have E1M for X component, you have E1mx here. Okay, and then you have resolve E1my here. Okay, so E1m you have negative because it is left side, E1m cos theta, negative 7.2 times 10 power of 3, cos theta is 0.8. So you have negative 5.76 times 10 power of 3. E1my is E1m sin theta, and then 7.2 times 10 power of 3, sin theta is 0.6. So you will have 4.32 times 10 power of 3. Next, E2M just in X component, so you just write down 1.8 times 10 power of 4. And then Y component for E2M is 0. Then you sum up your EM there, which is for summation E in X component, you will have 1.22 times 10 power of 4. Okay, and then for EY, you have 4.32 times 10 power of 3. Okay, after you did in your table, next is you can write down the magnitude. So your magnitude is EM is square root summation EX squared plus summation EY squared. Substitute your value, 1.22 times 10 power of 4 squared plus 4.32 times 10 power of 3 squared. So your EM is 1.29 times 10 power of 4 Newton per Coulomb. Okay, how about your direction? So your direction will be theta is tangent inverse summation E Y over summation EX. So your theta is tangent inverse 4.32 times 10 power of 3 divide by 1.22 times 10 power of 4. So theta you will get 19.5 degree. Okay, so 19.5 degree above positive x axis.